All right, here I am again. I'm going to try to finish up on part 2 of the pump control. It's going to be very basic pump control. I'm trying to keep my videos below 15 minutes. I mean, if somebody wants me to do something longer, I will. I was told, a friend of mine said, "I need to stay 15 minutes or less." Nobody's going to watch it and they get to 30 minutes. So anyways, I mean, each little section somebody has, like this question got asked. I don't mind going in there and trying to answer questions. People try to help them out and help you along your learning cycle of being a PLC programmer. I mean, I would like to get a lot more of us out there, especially a lot more of us out of the electrical field into it, instead of all the engineers taking all the credit for it. But anyways, we'll open this up. This is my NV3. I got it renamed Touch, but it's NV3. This is what you program your FT1A Touch, which is what the viewer was using, I believe, is an FT1A Touch. So we're going to program this and that. All right, let's go ahead and let's just rename that with buttons. We'll call it buttons 1. Who cares? Okay, we're going to use the FT1A C12. That's a 12IO relay, pretty much PLC. We're not going to communicate with any external devices. We're going to click through that just for the time's sake, because it's going to take every bit of 15 minutes to do this, and I'm trying to keep these videos at 15 minutes. Okay, we give this thing a minute. Should throw us a screen. There we go. You try to rush it, it'll throw you an error code on this program. It does for me anyways. Okay, this is our work area for our HMI. And I like to go first to the actual ladder diagram is what I like to do. So we're going to go to View. This little normally open symbol in NV3 is your ladder diagram. You cannot use WinLDR. When you use an HT or a FT1A Touch, you have to use NV3 that has the embedded ladder program. That's the only way I figured out how to use it. The only way I've tried, honestly, too. And they change these around. I don't know why they do. They change their programs up just a little bit from each one. I don't know why. I wish they had one program that done all, but they don't. Maybe one day Santa Claus will come and we'll get one program that does everything, all their devices. But anyways, here we are in our program. This is our ladder program. Go to View. Just some stuff you can do. You can get rid of some of this stuff. We'll use the info window. We'll leave it up. So I'm going to show you something on it later. Project window, we get rid of that. We can get rid of cross-reference. We'll get rid of property sheet. We'll leave our toolbox, tag editor, and info window. Toolbox, we can drag some tools out of here. We can come home, drag tools out of here, or we can keystroke them in. I'll show you how to do both of those. All right, we're going to tag editor first. Anytime I write a PLC program, unless it's something really, really small or something I'm just tinkering with, I'll go through the flow or the sequence of work of the machine I'm doing from start to finish, where the part enters, the part comes off the roll, where the water enters the system or whatever, and I'll start from there and start sequencing stuff out as far as my sensors and my inputs and my outputs to my pumps or my motors to my turbines or whatever it might be. And I list all of that stuff right here. That way I already have it in. So right now, and I'm going to put some real world buttons in here. We might not use them, but I'm going to show you. We'll put, I'm going to call it motor 1. All right, then we're going to have motor 1 overload. Because remember, he wanted to run them through an overload. Well, I don't know if you've seen the question or not, but he wanted to see it going through an overload. We'll go motor 2. Motor 2 overload. Oop, let me learn that spell. Okay, so we got an input to start motor 1. We've got an input to start motor 2. These are all physical. We have a physical input from our overload contacts on our starter for motor 1. We have an input from the physical contacts of motor 2 starter overloads that feed back to the PLC that tells us the motor's overloaded. Okay. Let's go up here. We'll get us some outputs because we need something to actually turn the motor on. These are what you would feed to your A1 and A2 on your motor contactor. Usually, though, I'm not trying to veer off the topic. Usually when I use a motor starter, whether it's an IEC starter or whatever, I usually put a relay and I run 120 volt coils on my starters just because the amperage on them, it drops the amps way down. If you use 24 volt coils, it seems kind of they break down faster to me anyways. So I'm gonna that's a side note. If you start designing motor controls, I would run 120 volt and use relay, and we'll get into cycles and stuff like that later. Motor 1, we're gonna say contactor. Okay, motor 2, contactor. You know what? Let's put it's a starter because it's got a. Let's do it right, Roy. It's a starter because it's got overloads on it. It's not just a contactor. So let's call it what it is. Yes, there is a difference. Motor 1 starter. Okay, we got motor 1 starter, motor 2 starter. Okay, we're going to use HMI to start this thing. So we're going to go ahead and get us some HMI bits over here also. These are our memory bits coming from HMI into the PLC program, the ladder. Let's say it's all embedded in one program in this. Let's go ahead and go motor. Start. I'm trying to figure out how I want to do this. We'll go motor 1, start, 2, start. I'm doing several different ones for things because we're going to do some different kinds of buttons if I can fit them all in this one little sequence here. We'll start with the top one, motor start, and I'll kind of show you. We'll go with this and see what we can come up with. Just that's the best way to do it, I guess. Okay, so let's go ahead and let's put a button on here, or an input from a button. We're going to bring this from the HMI, remember? So we can grab a normally open here. Okay, we can also type in A and hit enter, and that gives us a normally open. Showing you a few different ways. I know the device is not assigned. Let's cancel it. Okay. Or I come over to toolbox, go normally open, drop it in, and double click it. Okay, let's go. We're going to go with our memory bit. I had a brain fart there for a second. Motor start. Okay. Okay. See, since we did everything in tag editor, it's already going to have our comments up here telling us what each one of our bits is right here. Okay, and I'm going to show you real quick something about proofing your PLC program since we're right here this quick, this close. When you start to do a program before you even load it in your PLC, it's real wise for you walk all the way out on the plant floor or wherever you're at and plug in your PLC and go, oh crap, it won't go in for some reason. What's wrong? While you're still at your desk and you get your PLC program finished, hit that convert button. If it's not right, it'll come up with a deal like this. It'll say ladder program conversion failed. Confirm the error details listed under info window. Okay, it's not down there yet because I haven't clicked OK. Click OK. There you go. Main program rung 1, line 1. End should be connected to the left power rail. All right, end is not connected to the left power rail. It's connected to M0. So I got something wrong. When you have an end line, you should have an end coming straight across from your left power rail, nothing in between there as your last rung on the ladder diagram. And usually self-populates itself whenever you're in Win LDR. So to fix that, we're going to come over here now. Let's go ahead and put us an out. I did it by typing in out. Okay, we're going to go here to our outputs, Q, motor 1 starter. Okay. So it got rid of that end, and here in a minute, we'll show you. I hit convert. Okay, see? Ladder conversion succeeded. That means that is a good program. It has an input and it has an output. Okay? So right now as we have it, we have an HMI button that's going to start Q0. All right, let's go ahead and get us a rung comment in here so we remember what this is for. This is real good to segregate your components in a PLC program, just to make it keep it real tidy for one thing, and also to keep you to be able to make it to where you can navigate around it real easy. Say you have a PLC program loaded in your motor control panel out there. Okay, and you start running it, and something starts acting funky with motor 2. You're not quite sure what it is. It's running, but something's acting weird. Maybe it's starting when another motor's supposed to start, and it shouldn't be doing that. Okay, well, you can always say, okay, that's motor 2. You can come back to your rung, you'll see, and look on your rung that says motor 2, which we haven't made that yet, and you'll say, there's my motor 2 control section. Let's look at motor 2. Another good way to segregate them is make subroutines. These little tabs right here, you can add tabs in here. Those are subroutines. That's a good way to segregate different parts of control also, to where it's quick to find. But we'll get some more into that later also. Just kind of some a little bit more up stuff. Not confusing. There's nothing about PLCs confusing, so don't let me scare you or anybody else. If you're an electrician, this is really, really easily attainable for you. Don't let it spook you at all. Okay, let's start us another rung. This is going to be motor 2. So I'm going to go ahead and edit my rung comment. Change my color. You can change it whatever you want. I'm just doing what I usually do here. Green. Motor 2. Control section. Okay. I'm not going to get too fancy with it. It's not going to be real pretty, but this will get us by. Okay, I want to use an alternate button. An alternate button, if you remember, is one when you push it, it lit up and it turned on a bit, and when you pushed it again, it turned off and turned that bit back off. Okay, that's what we're going to set this up for, is an alternate button. So I push it, turns on the bit, button lights up, or changes states. We'll go to that here in a minute when we set it up too on the HMI to show you what I'm talking about. And like I say, I don't know how far along we'll get, but we have to do one little section and come back and do another section. But we'll get there. If you want more and more, just keep saying so, and we'll get there. So then we're going to set this up for an alternate. So what I'm going to do now is either type in a B, which brings me a normally closed, toolbox, B, normally closed, basic, B, normally closed. I know I keep doing this over and over, but you see it over and over, it's going to make it a lot easier for you to navigate around and figure stuff out. I want to use that same bit at M0. Okay, so you can look here. Let me show you another way too. You can also go right here if you know what it is, M0. Okay, I know it's M0. You can type it in instead of going through all of the other part if you want. Okay, I want to out. Okay, and I know this right here is Q1. Okay, so I just typed in Q1. That's just a faster way to do it. All right, now, show what we got on our PLC program right now. As of right now, when motor 1 is off, that button's off, this bit is low. In other words, it's 0 or off. Q1 is starting. Don't let these normally closed fool you. Some people get confused over easy stuff like this. This is really, really easy to just wrap your mind around it, and you'll understand it. Okay, when I turn on the button on the HMI, this goes off or goes to false. Basically, turns that off. All right, and this one comes on. So basically, is what this bit's looking for. It's looking for that to be true. When it's true, this goes off. When that's false, it comes on. When it's false, it's closed. In other words, when that bit is off, that's normally closed, just like a normally closed contact laying there on the desk with nothing hooked up to it. That normally closed would pass power through it if you hooked a battery to it and a little bulb. Same thing here. So switches off, normally closed, closes back shut. Now you got power going to Q1. I hope that kind of makes sense. Let's expand on this a little bit. All right, I'm going to append. Append a ladder line, adds a rung below. Insert a ladder line, adds a line above. We don't want to add them above, we want them below. We want them to look clean, so let's append ladder line. Okay, it's our second line of logic on each one of them. All right, this is what I want to do now. I've got a motor overload. Let's go ahead and put us a motor overload in here. All right, so I'm going to come in here. I'm going to hit a B because this is going to be a normally closed. Okay, this is going to be motor 1 overload. Okay, so this is an and. So when this one closes and that one remains closed, this comes on. Okay, we're going to go right here and do the same thing. We're going to add a normally closed. See, normally closed. I hit B. This is what you type in to get any of this stuff on here. I'm just showing you different ways to do it. We're going to go down here and get motor 2 overload. Okay, now this is an and. When this one's closed and that one's closed, then that is on as such. See, this one's closed, that one's closed because the motor is not in an overload state. The motor's running. This one is not closed at the moment, but this one is because the motor's not in an overload state, but that is not running because you don't have this and that in the states they need to be. This is not on and that is not open. Or that is on. That's where it's supposed to be. I'm sorry. So kind of keep that in mind. You want to play around with these. Some people get confused with normally closed and normally opens, but just think relays. Just like an ice cube relay. I can't get any simpler than that. It's like an ice cube relay. Think about how the power flows through one of them when it's laying there on your desk. Same kind of deal. Okay, now let's make our little bypass here for our overloads. Okay, so what I want to do here now, if this overload trips down here, I want this motor to turn on. So that's I3. So right here, I'm going to put I, normally open. Okay, let's go. I3. Okay, so that's motor 2 overload. So if motor 2 overload opens up, guess what? This is going to be my and with this and turn that on. We'll go through that here in a second too. Okay, we're going to do the same thing right here, except we're going to use the overload from up here. So we're going to put another A. Okay, and this one is going to be I1, right? Took me a second to think there for a minute. Okay, so now let's go through this. I'm going to turn it on. We'll see what happens. All right, so we have this and this. That has power. All right. Now, this overload, if this, here, I'm going to show you how to go to online. We're going to get a batch out, or a custom out of here. Custom monitor. It's easy, better sometimes to do it this way. Let's go, I'm going to go I0, enter, I1, enter, I2, enter, I3, enter. And we'll let you just look at the outputs and see if they're green or not. We have to change all these. These are bits. They're not words. So we got to go over here. I'm showing you a little extra stuff here, but maybe this will help you. You can always rewind and catch it and whatever. Okay, now you'll see what state all of these bits in. None of these are on. That's green because that's off. All right, if I click this, see it change state there? That's turned into a 1 or on or true or make, whatever you want to call it. Okay, so here's our problem. We're right here running pump motor 2. Gets a bunch of trash sucked up in it. It's just terrible, terrible trash. All right, and I3. All right, it overheats that motor. All right, I'm changing it to true over here to change my bit. All right, now what just happened? What just happened was when I turned this bit off here, I didn't really turn it off. I turned it on. I took it out of its normal state. So that relay opened up. It's no longer closed. It still looks closed there, but that green light went away. So it's really opened up. This one actually closed, completed this AND circuit here and turned Q0 on. Okay, if I change that back to 0, the overload condition goes away. Now that motor starts back up. The other motor drops back out because I have my AND back together here. Okay, I'm at my HMI. I'm going to push. It's 19 minutes already. Whew. Anyways, I'm going to go to my HMI and pushing this button because I want the other motor to run. Okay, motor 1's running. I have M0 and I1 is normally closed running, so my relay's pulled in, or my starter's pulled in, sealed. Okay, now same thing. If I have this I1 here, pull out, look what happens. I1 bypasses down here, creates an AND circuit here, turns on Q1. Okay, this is an OR circuit. This is an AND circuit. This and this is an AND circuit. Any two of these, this is kind of like an AND OR. So hopefully you get that part of it. Let's all right, so there's our normal state. We have M0's on. Turn M0 off. There we go. Okay, so let's go to the HMI before it gets too long here. I want to go to the HMI section. All right, HMI. Let's go to home. Let's get us a button. Get a bit button. I'm not trying to go too fast. I'm going to go to alternate or alternate, whatever you want to call it. I want it to work off of M0. Just like I called it a while ago, motor start. See, it already tells me right here what it is, it motor start. Now, we'd want to probably change that because I'll show you why here in a second. Let's go to view. I've already shown you how to do all this, but I just don't want it to look that bad. I'm picky. Let's go to symbol factory. I know this is running over just a little bit, but we're going to go red. We're going to call this motor 1. You'll see what I'm getting at here in a second with this type of button. Okay, let's get another one. We're going to get a green one that's lit. We're going to call this one motor 2. Okay. All right, let's pick that. Select. On. Browse. We're going to pick that. Select. All right, let's go to registration text. When it's on, we're going to say motor 1. Set by state. The other way is going to be motor 2. Let's see what we got. Okay, we're going to leave it big like that. All right, so basically, when this button is not pushed now, this is alternate. Okay, that means motor 1's running. You got a red light on. It says motor 1. So that would be, well, actually, I did it backwards. That's what I did. I did do it backwards. Here, let's fix it right. I'm picky. That's actually motor 2. That was motor 1. I'm sorry. Everybody messes up. Ain't nobody, one person perfect in this whole place that I know of. Okay, so we go back to save. All right, now motor 2 is running because that's lit up because of our PLC program. I'm not going to simulate it between. I'm going to show you. So motor 2 is running, but if I push that button, that's going to light up. You can't see the text because I didn't change it to black. It's white. It says motor 1. All right, and this right here would be motor. That would be pushed, so motor 1 would be on. And you can invert a button also if you wanted to, a different way, but that's how that would work. I hope I didn't confuse that too much, getting in a hurry. I'm not really trying to get in a hurry, but I'm running over a little bit. I'm already at 23 minutes. But anyways, I hope this helped you out, bud. Like, comment, and share with your friends. And if you haven't subscribed to my channel, please do. And if you have any questions, comments, requests, please ask away. I'll do what I can. I'm not the smartest guy in the world, but I'll try to help any way I can, anybody, just about. So if you like my videos, keep on them, keep watching them. Hope you learn something, and maybe you can make yourself worth a little more money and go in there and tap on that boss's door and get you a raise. That's what I'd like to hear about anyways. But anyhow, we'll see you on the next video.